Welcome to Ask and Learn.
To use the ratio test here, it would be helpful to have a formula for the nth term of the series. Now we see here our first term, A1, A2, and so on. And if we keep going on in this pattern, you see in the numerator, we start off with 2, and then we keep adding 3. So it looks like we should have 3n minus 1. And you can check if n equals 1, you get 2. If n equals 2, you get 5. And each time n increases, the numerator includes an additional factor of 3, increases by 3. Now in the denominator, you see that we have 3, 5, and so on. And in the denominator, we're increasing by 2. So this time we should have a 2n in there instead. But when we plug in n equals 1, we'd like to get 3. So we should do 2n plus 1. So here's our formula for the nth term. And so now we go to the ratio test. This, we look at the limit. N goes to infinity. An plus 1 over an. So now I could drop the absolute values because all of our numbers are positive. And now here, let's do an plus 1. So the numerator over here. And then we would keep multiplying, and then we would include the next term. So that's the numerator for an plus 1. So I'll do this in blue. And the denominator. And then we increase n by 1. And now we'll divide by an, so we'll just use our formula up here. And now, as usual, we'll go ahead and take that denominator, flip it upside down, and multiply it. So here, I'm running out of a bit of room here, so let's see if we squeeze this in. And notice the very last term over here, if you simplify this, that's 3n plus 2. And the denominator, and then the very last term here, that's a 2n plus 3. Okay, now we're multiplying this by this thing after we flip it upside down. And now we'll start canceling out as much as we can. So we look at the denominator over here, and you see that you could cancel all the terms except the last one with this numerator over here. So that leaves us with a 2n plus 3 in the denominator. And how about the numerator? It looks like we could cancel, and then here, sorry, this should have been a 5. It looks like you could cancel everything up to 3n minus 1, and then you're left with 3n plus 2. At this point, if it helps, you can use L'Hopital's rule to evaluate that limit. In either case, you get 3 over 2, which is bigger than 1. So the series diverges by the ratio test.